In this question, we're given a series of ionic compounds and asked to determine whether the solution they form is acidic, basic, or neutral. So to do that, we need to look at which ions are in solution. So in this case, we have Fe3+ and I minus. Well, if we look at I minus first, because Fe3+ is a bit longer of an explanation, I minus is the conjugate base of HI, a strong acid. So this is a weak base. And therefore, it's within reason neutral. However, let's look at Fe3+. And this is a bit of a complicated case, as I said. When iron 3+ is in solution, it coordinates water molecules like this. So 6 water molecules, it forms a hydrate, if you will. When this molecule interacts with water, it can actually donate a proton to the water. And what you get is Fe5, it was 6, OH. And instead of being 3+, it's now 2+. Plus H3O plus aqueous. So in this case, hydrated iron 3+ donates a proton to water to form H3O+. So this is acidic in solution. Well, if this is acidic and this is neutral, the overall solution is going to be acidic. Note that this happens for ions, the ones that I saw on Alex, and there may be others, for things like Cr3+, even Fe2+, although to a much less extent than Fe3+, Al3+. The general rule is that it's highly charged metals like Al3+, and transition metal ions that are doing this. Note that this will not happen for things like magnesium 2+, a main group metal with a 2+ charge, or it won't happen for certainly 1A metals. Okay, they are going to be your weak acids. Let's look at the next case. We have NH4Br. Well, if we look at this, what do we have in solution? Well, we have NH4+, and we have Br minus, and I'm going to write it over here so I have a little bit more space. Well, if we look at NH4+, this is the conjugate acid of NH3, which is a weak base. That makes this a relatively strong acid and therefore acidic in solution. What about Br minus? Well, this is HI, HBr. This is the conjugate base of the strong acid HBr. This is a strong acid. Therefore, this is a weak base, and therefore, again, it is neutral. So, one of these two ions is acidic, and one of these two ions is neutral, so therefore the overall solution must be acidic. Let's look at the last example. We have Na+. 1A metal ions do not do things like this. They just float around in solution. So this is neutral. Now let's look at the other ion, Cn-. Cn- is the conjugate base of weak acid HCN. This is a weak acid, which makes this a relatively strong base, which makes this basic in solution. So we have one that's neutral and one that's basic, so the overall solution will be basic. So in order to solve this problem, we need to look at the ions that are in solution and often look at their conjugate acid or conjugate base to determine whether they are strong acids or weak acids or strong bases or weak bases, and then we can determine the overall pH of the solution.